Hey guys, welcome to the fourth video of Module 2. This is Mehek and today we're going to learn coding in Tinkercad. So first, let's start by renaming this project. We just click on it once and now we can edit it and we can rename it to something like Coding 1. And now what we're going to do is we're going to drag an Arduino and a light bulb. We're going to make a very basic circuit today, guys, so that you guys understand the basics of coding and block coding. So as you can see, these are the analog pins and these are the digital pins. So digital pins have only two states, either high or low. High means the bulb will turn on and low means the bulb will turn off. We'll see how we can incorporate this while we're coding. You can see that a light bulb doesn't have any polarity, which means it has no particular positive or negative terminal. So we'll just connect any of the terminals to power, which is like to any one of the pins, say pin 10. And we're going to connect this terminal to the ground. Generally, the wire which is connected to power is red in color, and the one connected to the ground is black in color. So that's what we're going to do. We're going to color code it so that it's easier to understand. And what do you guys think now that the circuit is complete? So this simulation, we can start the simulation and you might be expecting the bulb to turn on, but that doesn't happen. Why? Because we need to code. Coding is very important because it allows us to do whatever we want. And Arduino works by coding only. So as you can see, there are multiple options over here. If you click on this one, there are blocks plus text and text. So Tinkercad has this great feature called block coding, which helps students to code and learn, even if they don't know coding. So I'm just going to show you how this works out. We're just going to drag this to the dustbin and delete it. We're going to take the set block from over here, from the output section, and we're going to select the pin. Which pin were we on? 10 over here, pin 10. We're going to set the pin 10 to high, which means the bulb will turn on. Now when we start the simulation, we'll see that the bulb is on. But what if we want a blinking bulb? Can we create that too? Of course we can. Now what we're going to do is we're going to go to the control section. And over here, we're going to take the wait block. So now what happens is, the pin 10 gets a high value, so the bulb turns on, and then waits for 1 second. Now what we're going to do is, right click, and we click on duplicate. So now we're going to turn this one to low. So what is going to happen is, this pin is high, means the bulb is turned on. We wait for a second and then the pin 10 is set to low, which means the bulb turns off. And then we wait for another second and then it keeps on repeating until we stop the simulation. So now when we start the simulation, you can see a blinking bulb, right? Okay. So only Tinkercad has this option for block coding. So people who are still learning, who are still beginners, can use this. But coding is always preferred because it can be used anywhere. So we're going to go to the blocks plus text part. And because we created the block, we coded using the blocks. So a code of it automatically gets generated. So now we're going to understand this code, what this code exactly does. There are two main functions, setup and loop. What setup exactly does is, it sets up the model and runs only once, whereas loop runs multiple times until we stop the simulator. Inside setup, we have one function called pin mode. In pin mode, we provide the pin number and if the pin will be an output or an input. So over here right now it's an output because we're getting an output because the bulb is an output device. But if we use something like a button, instead of output over here we're going to write input because we provide an input, right? So now over here in the loop function, we can see there's this function called digital write, in which we provide the pin number, and if the state of the pin is high or low, that is whether it provides 5 volts or 0 volts, whether the bulb will be off or on, right? And we use the digital write function because this is an output. If instead of an output this would be input, then we would be using digital read, which I'll show you in the next circuit. Again, we're going to use a delay instead of wait, like we used a wait block. Wait is just used in layman terms, but in coding we use delay. Delay 1000. This is 1000 because it's in milliseconds. 1 second is equal to 1000 milliseconds. So that's why we've used this. And now we're going to write again. Digital write 10 low. Instead of high, we're going to use low. And delay 1000. And now it'll do the same thing because we have made no changes to the code. So this will just keep going on. So basically, this was the code. Guys, please do try to code by yourself without using the code blocks, because now you understand the code too. Now, we'll go on to the next circuit. So, for this circuit, we're going to use an LED, a push button, a breadboard, and an Arduino. So guys, just pause the video for a few minutes and make all these connections. Be very careful of the connections, that's all. So, now that you've made all the connections, now, you might have noticed that the anode of the LED is connected to power, but what about the cathode? Will it be directly connected to the ground? No, it's not directly connected to the ground because otherwise the current flowing through the components would be extremely large and would damage them. So that's why we use a resistor instead. But what will be the value of the resistor? Come on, let's see how we can calculate that. So generally, an LED is rated for 30 milliamperes. So the current will be 30 milliamperes. And the voltage supplied by an Arduino is 5 volts. So by the formula V is equal to IR, we're going to find out the resistance, which is going to be V by I. Okay, so now when we substitute the values, we're gonna get R is equal to 5 volt upon 30 milliampere. Now when we convert milliampere into ampere, we'll get 5 volt upon 30 into 10 raised to power minus 3 ampere. We're gonna get 5 into 10 raised to power 3 volt upon 30 ampere. So the solution will be 166.6 ohms. Okay, so this is going to be the value of the resistance. So this is what we're going to put over here, 66.6, and don't forget to change the value. It should not be kilo ohm, it should be ohms. Okay, so this is going to be the value. And now, how do we connect a push button? We can connect the push button by connecting any two of its diagonal legs. So we've taken these 2 diagonal legs, and one is connected to the 5 volt and the other can be connected to any other pin. But we'll have to add a 10K resistor or a high resistor between the ground and this pin. Now, why do we need to do that? I'm going to explain to you why this resistor is important. Now, just think of this switch as the push button, because it is nothing but the push button. What is a button essentially? It basically has a switch inside of it, which closes and opens according to the situation. Okay, whenever it is pushed, the circuit is closed, which means the circuit gets completed, and when it's not pushed, the circuit remains open. Right, so imagine that this resistor is not there. Okay, and the button is not pushed. So the circuit remains open. So what is going to happen? This pin 2, and in this case, in our case, we have pin 7. So what is going to happen is this will become a circuit on its own, and this will be a complete circuit. Current will flow through it. So this pin will become high. 2 will become a high pin, which is 7 in our case. 7 will become high, and the LED will turn on. That means whether or not the button will be pushed, that will not matter. The LED will remain on. Now, imagine that the resistor is still not there, but we push the button, we press the button, so the circuit is complete. When the circuit gets completed, then ground will be directly connected to 5 volt, which will lead into a short circuit. This bulb will get short circuited, right? So that's why a resistor is very important. So now let's go back to the circuit and understand the code part about how we'll code this. So we're just going to take everything and put it into the dustbin. And now we're going to create a new variable by the name of button. We're going to go to the variables section, and I've already created it over here, but you can just click on this and create a new variable. Say, I'm saying button push, right? So I'm going to use this button push, whatever. I'm going to take the set block of it. Okay, I'm going to take set button to input. I'm going to go to the input section. I'm going to take this one, read digital pin, and I'm going to drag it over here. And which pin is it? Pin 7. So we're going to select pin 7. So what happens over here is we name a new variable by the name of button, and we give it the value of whatever is the value of this pin. That means if this pin is high, then what is going to happen is this bulb is going to be high. Like this pin will become high and the bulb will turn on. The LED will turn on. If this pin is low, that means this pin will be given the value low and this LED will turn off. Understand? I'll explain again, guys. We go to the control section, we take the if-else block. So what do we need to do? When the digital pin, we have to check the value of the digital pin 7. So it's gonna read. For read, which function will we use? Digital read. Instead of digital write, we're gonna use digital read. In the last circuit, we used digital write, but this time we have to get the value. So we're gonna use digital read. Okay, and now we're gonna go to the math one. We're gonna take this one, and what two values do we have to compare? We have to compare the value of this. Like we have to check if this value is high or low. So we again go to variables. We take this button and we select equal to, and we go to math again, and then we select this one and we set it to high, right? We'll set it to high. So basically we're just comparing if button is equal to high. That means when the button will be high, button is nothing but this pin. If this pin, the value of this pin is high, then the LED will have to turn on. That means we'll write the high value to pin 11, which means we'll go to output, set pin, which value is the 11. So we're gonna write high to pin 11, which means it will turn the bulb on. And now we're gonna take this again, else if the button value is low, which means the 7 value is low, so this LED will turn off, which means the value assigned to pin 11 will be low. So we're gonna assign low to pin 11. Right? So we've completed our code and now we'll start the simulation. So look, when we press the button, the LED will turn on, and if we don't press it, it will turn off. Now, let me show you what happens if we delete this resistor. Just delete it. We just click on it and press delete. It gets deleted. Now when we start the simulation, you'll see, like I explained to you, the LED will turn on no matter what. And when we press the button, there are many chances of it getting short-circuited. So guys, now that I've explained it to you using code blocks, you yourself go and discover the code part of it. You understand the code part of it. I've explained everything to you. Try to decode it, try to understand it, and if you don't understand it, don't hesitate to ask any questions during the Q&A session. Hope you understood this concept very well. Happy learning. So guys, your assignment for this video will be to make any circuit with any of the sensors you want. You can refer to any source on the internet to understand, or you can always write to us or ask us questions in the Q&A session, but do complete this assignment as soon as possible. Thank you guys.